last time we looked at some basic concepts of the openhdmg library itself. We looked how it is structured, what it can do more or less, but most important, we loaded a file, an electromyography recording with the decomposition, and we looked at the content of this file. This was important both to give you a first approach to the openhdmg framework, but mainly to introduce you to the various Python data structures that you will always need in your experience with Python and data analysis. Today, we do a step further, so we move a more, let's say, hands-on approach, and we will look in particular at how to create, how to modify these data structures that we already saw, and most important, how to make operations with them. So we will not just look at them, how they are, what they can do, but we will really do things with them. And before we start, I remind you that we have the discussion forum where you can ask questions, ask for support, but you also find the scripts that we provide, and the one that I shared for today's class and so on. So have a look at the forum. If you already didn't do that, leave a star to our repository, which is of great help. And a very important thing of today before we start is that the openhdmg project is a community project, and because of that we really take into account your feedback. So I was really happy to see that some of you took the time to fill the form we sent after the classes. You gave us a feedback on how we can potentially improve the classes, and we took all of them into account. So we have been requested to share the code in advance so that you can practice, check if everything is working. You can go through the code at your own speed before the class. We did so. I apologize if we didn't have too much, let's say, advanced, because it was shared yesterday night, the code, but we did not manage to prepare it any earlier. We will try to improve on that for the next time. And then we will make the classes more interactive, so we will provide you with some tasks that you need to do. We will also provide links to additional resources that you can use to get a deeper knowledge of what we look at during the live classes, because obviously there are so many things to know that are impossible to cover just with a short presentation. And we had a request from one of our participants that asked if it's possible to have a certificate of participation. We didn't think at that at first, but I think that's a good idea. So if you need a certificate to, I don't know, for your university, for credits or something else, you can ask us for the certificate of the single class if needed. But otherwise, at the end of the course, you can also ask for a certificate of completion of the coding classes. In that case, since many people are following the classes at other times, because we understand that this time slot is not suitable for everybody, the certificate will be released also to those that will follow the course on YouTube, so looking at the recordings. So in case you want these certificates, if you need them, or if you would like to have them, just drop us an email and we can share the certificate with you. For the certificate of completion, obviously we need to finish the coding classes first. Okay, so we don't have many more slides. I think we are ready to start coding. Yeah. Okay, so we go back to our Visual Studio Code. Everything is as we left it last time. So if you remember, we created our first script, which was class 1. So for today, we created a new script, which is class 2. Same thing as last time. We need to have a terminal. We need to activate the virtual environment, which could have different names in your case. So whatever it is, just check that it's activated and it's the correct one. And so let's start coding immediately. So today we look at how to create and modify, operate the data structures. So the lesson will be a bit more distant from the electromyography analysis itself, because this will give you a knowledge of the coding fundamentals. So it's difficult to make examples on real data sets. So we will have study data sets that are very simplified, that are simple and fast to create, but that will allow you to easily understand what is happening in the code. The idea is to provide you with this extensive information on basic coding skills so that we can move on the next classes to look at more, let's say, advanced coding concepts that are the object-oriented programming, so functions and classes, attributes, and so on. So please be tough, at least for another 2 classes with the basics of Python coding. And after that, you will have all the tools necessary to use a library like openhdmg or any other library. So we will eventually start looking at electromyography analysis. Okay, so in today's class, we start by looking at lists. The data structures we will see today are the same we saw last time, so you should be familiar with all of them. Just try to understand how to use them, okay? So to create a list, we first of all define the name of a variable that can be my list, or be better to say the name of an object in Python. To create lists, we simply use square brackets. I told you last time that each type of bracket has a different meaning in Python. So for creating lists, we simply we put values inside brackets. So in this case, I can do 1, 2, 3. So I can put some integers in my list. I can put float values, so values with decimal places. I can put strings. I can put Boolean values, so like true or false. And I can put, just to show you the difference, the same text, which is true, but in this case it's a Boolean value. And in this case it is a string, so it's a text. And there we are, we created the list. Last time we saw the type function. So if we print type my list, we will see that this is a list. Okay, so creating lists is really, really simple. Now that we have our list, we may want to look at what there is inside, because now we created it, so we know what there is. But if we don't, or if we anyway we want to access a specific object, we need to do a task called indexing. Indexing in Python is almost always performed with square brackets. So if I want to look at the first element in my list, I can print my list, square brackets for indexing, and 0, because Python is base 0. So to index the first element, we use the index 0. And as you can see here, we have 1, okay, which is the first value. If you, I don't know, put 4 here, we see the word hello. So indexing is very simple if we only need one value. It's simply done by position in lists because we don't have any element describing what there is in any position compared to dictionaries, as we explained last time. So indexing is straightforward. A nice feature about Python, I can say that is we can access lists also in the opposite order. So instead of going from the beginning to the end, we can go from the end to the beginning. In this case, with -1, we will access the last element, which should be true, the string true. But we can also put, like, for example, -4. And in this case, we see hello. Okay? This is another useful thing because let's say you don't know how long is your list. You can, of course, verify the length of the list and then use this value as the index in your square brackets. But a much better and faster approach is to use -1. Another interesting type of indexing is slicing, which means accessing a range of consecutive elements. So for example, we can do my list 2 colon 4, which means access the element, access my list from element 2 to element 4. And as you can see here, we see 3 and 4.5. So in reality, we have 2 elements. This is because, as I told you before, Python is in base 0. Because of that, when you create any type of range, it doesn't matter if this is to index a list, if this is from a range function or whatever it is, we always consider the starting value, but we do not consider the ending value. So if we want to index the element in position 2, we got 0, 1, 2, we have 3. Then we index the element in position 3, which is 4.5, but we do not index the element hello, which is actually in position 4, because the ranges go from the starting value to the ending value -1. This is complex at first, especially if you are working with MATLAB, this is an enormous difference. This will cause most of your errors when you write the code. But once you get used to it, you understand that this is fundamental for the correct functioning of Python, because being in base 0, if you know that your list has 10 elements, if you want to access the 10 element, so if you write here 10 instead of 4, you will get an error because your 10th element will be the 9th index, okay? This is simple, can create some confusion, so I want to start immediately with the hands-on section, and I ask you to perform this simple task. So I ask you to access the string word, which is words, yeah, doesn't matter, the string word inside my list, both indexing it as the 6th element, so starting from the left to the right, or by indexing it as the 3rd last element, so starting from the end, going back to the beginning. Okay, I will give you few minutes. Let me know if you have any doubt, if it's not working, and then we look at it together. I think we can go quite fast on this first task because it's quite simple. So if we want to look at the 6th element, we need to use the index number 5. This is because, once again, Python is in base 0. I repeat this over and over, but it's a very important concept. So if we print my list 5, we see word. If I want to access it at the third last element, in this case, this is very simple. We write -3. So in this case, as you can see here, we get word. When you go toward negative values, the base 0 concept doesn't work anymore because you don't have a -0 position. So positions go from 0 to any number. But since they start from 0, the first value in the other direction will be -1. Okay? Perfect, I think.
Sorry.
Yeah.
I have a question because I don't know if I think I skipped or forgot this step, but if I want to just like evaluate on one line of code and not the complete code, how do I do it again? So
No,
because if I click on running it now, it runs the whole script and then I don't get the results.
Okay, so I think the best way to do it is just create a new script and write there whatever we are doing. If you want to run the single line, you can select the line you want, right click, run in interactive window, and then you run a selection line in interactive window. But if you didn't do that before, it will ask you to install some libraries to do so.
Okay, so it makes more sense to create a separate code and just copy and paste it one by one.
Yeah, I think it's the best approach because the interactive window, of course, has limited functionalities compared to the scripts. And also, when you end up building your script for the analysis, you will definitely use a real script, not an interactive one, because you have less possibilities to explore the plots, for example. You have issues in interacting with graphical interfaces and so on. So this is very convenient because you can go line by line and execute just what you need, but it has some limitations. You can try it yourself, but I always encourage people to work on real scripts.
Okay, thank you.
No, you're welcome. Okay, so we have our list, which is composed of different type of things because we can put whatever we want inside the list. So a list is a fantastic container when we have things that are organized with some understandable order, which is the position. And we can obviously modify these lists because the lists are dynamic objects. For example, I may want to add a new value at the end of the list, so I can use the method append. As we saw last time, methods are functions, but specific of an object. So in this case, the list is a class, and the classes are a collection of attributes, functions, and so on. In this case, we call them method, but as you can see here, as last time it is in yellow, it requires the parentheses, so we simplified it saying that it's a class. Inside this class, we need to specify which object needs to be appended to the list. So in this case, we can add anything. I want to add the string false, and then I can print again my list. Okay, as you can see here, I have my entire list, but I also have the word false that I decided to add. We have many functions of this type, obviously. We will just look at those that can be useful, because otherwise the lesson will be too boring. But for example, we can append more than one element. In this case, we may want to use the extend function. In the extend function, as you can see by the definition, we can extend the list by appending elements from an iterable. An iterable is any element that can be composed in sub-elements. The list is a perfect and most used type of iterable. So we can create a new list inside here that contains, I don't know, 10, 11, and 12. And what will happen is that we put 10, 11, and 12 after the rest of the list. Okay? If we want to put values somewhere inside the list, we can instead use the function or method insert. When we open the parentheses, we see the description, which is insert object before index. So I need to specify the index. As you can see here, it asks the function requires an index plus an object. Let's say I want to put it before number 2, which is in position 1. So the index is 1. The object is, don't know, the string inserted. And as you can see here, we have 1 inserted, 2, 3, 4, and so on. If I want to put the text at the beginning, I simply put 0 instead of 1, because the actual value in position 0 is the number 1. The insert method puts the object before the index that I specify, so it will become at the beginning. As you can see here, inserted, and then 1, 2, 3, 4, and so on. Okay, we may want to remove something. The same way, we have the method remove. We open the parentheses, and it says remove the first occurrence of a value. So let's say I want to remove the number 3. I put 3, execute the code. And as you can see here, I have 1, 2, 4.5. So the number 3 is gone. This is interesting, but you may also want to remove an object and know what has been removed. So in this case, there is the method pop. And as you can see here, remove and return an item at index. So with the remove method, we could have written, for example, hello, and it would have removed the word hello. In this case, we need to pass instead an index. The index of hello in this case is 0, 1, 2, 3, so it's 4. And the function also tells that it returns an element. So I can say removed value. So I collect in the variable removed value what is being returned by the function. And I can print remove value. So as you can see here, hello has been removed. And I can also print again my list to see if this has been really removed. And as you can see here, we have 4.5 and then we have word. Hello is no longer there. So we both remove something and we know what has been removed. And we can also use the removed value for any other computation, okay? Also, this part here has been passed. Maybe today's class might be a bit boring because we are just going through many concepts. But as you will see, all of them are similar. So you need to know what method you need. You call it, and then there is the documentation that explains you how to use it. If you obviously need more support, you can go on the web and look for the documentation, look for forums, tutorials, and so on. But for what we are doing now, I would say that the description is sufficient. So we can start practicing the second task. So this time I ask you to create a list which contains three lists. Okay? So you make a list, and inside the list you separate with the comma other lists. So you just create them with the squared brackets. This structure is called list of lists or nested list, and we will see later on that is more common that you would expect and is quite useful. The first list you create inside the main list should contain only numbers, just for exercise. And once you create your list, you can try to access the list in the first position, so the one containing only numbers, and then you can extend the list. As you have seen before, the list can be extended with the extend method, but you can also use the plus operator. So you write one list plus another list. It will be extended. And I expect this last task may give you some more issues that we will look together after the answer. Okay? Take a few minutes and let me know when you are done. Okay, while you continue, I start creating my list of lists, which is inside square brackets. And inside there, I put other lists. And this can contain anything. position 1 numbers. So this is how you can create a nested list. So you create your main list, which is contained in these yellow square brackets. And then you can put in position 0 another list, in position 1 another list, in position 2 another list. As you can see here, this list contains numbers, integers, float numbers. This one contains strings, this one contains Boolean values, so whatever you want. And to see what there is in position 1, I can print list of lists 0, okay? Because this is the first position. And there we go. Here we have 1, 3, and 10.5. Now I can create a new list, or you can create it directly inside the function. It doesn't make any difference. And so my new list is this one. And I can use the function the method tend. Okay, and as you can see, no, I did wrong. Okay. So we created a nested list. We created a new list by which we can extend my list of lists in the first position as requested by the task. And we use the method extend. So this time, this is not colored in yellow, simply because we are accessing something that is inside the list. So this can potentially be anything. And the Visual Studio Code is not able to catch that also the first element is a list. So it will not pop up in a new color, and it will not give you a description of what you need to do. This is why it's important to start from very simple structures where everything is straightforward and working well, and then move to a bit more advanced structures. So as you can see here, I did not create a new variable, which is containing the extended list of lists. This is because the extend method, and I would say most of the methods in about lists are modifying the list in place. So when you execute a method, the original list is being modified. So we simply modify it and then we visualize it. But as I told you, we can also use the plus operator. So in this case, we can use list of lists simply plus new list. As you can see here, nothing is happening. My list of list in position 1 is the same. It has not been extended because in this case we are not using a method. We are using a mathematical operator that is interpreted by the list as a sort of extend function, okay? So in this case, we need instead to create a new object that will contain the extended list. So we can print instead the extended list. And as you can see here, we have the original list in the first position plus the content of my new list. Okay, this is, I think it's creating troubles, maybe doubts, but is to show you that whatever we do might work in a different way. Lists method are modifying the list in place. If we use other approaches that give the same result, might work in a different way. So the plus operator is still extending your list, which is fast and convenient to write, easily understandable, but it's not modifying the list in place. At the same time, the plus operator may create confusion because it is not performing a mathematical operation in this case. And this is because lists are supposed to be used as a storage of information and not really as a tool of mathematical processing. You can somehow do mathematical operations inside the lists if you modify the single element, but that's not how they are supposed to work. So we have seen a bit of concepts about lists. We understood how this work. But now I want to show you tuples, which we didn't see last time. But tuples are similar to lists, are created the same way as lists, with the exception that they are created with round brackets, not with square brackets. So we can put once again whatever we want inside here. And you may say, so what's the point of this? We just change the parentheses. Well, tuples compared to lists are supposed to be, okay, we have a question. So you're asking if the plus operator is limited compared to the extend function. The plus operator has more or less the same functionality, but yeah, it can be confused quite easily. So if you only work with lists, it's okay to use the plus operator because it makes it easier and faster to write the code. But if you, for example, use arrays, which look like lists, because in the terminal they are represented with square brackets as well, you may not understand anymore if you are extending a list or if you are doing a mathematical operation between two arrays, for example. So the plus operator is convenient, is something you should know that is possible, but at the same time should be used with caution. So if you use the methods that are specific for the object that you are using, is generally better. And sometimes, maybe this is not the case, but sometimes they provide better performance in terms of computation. So thanks for the question. Just keep asking. Let's try to make this class interactive because otherwise these basic concepts will be extremely boring. So going back to the tuples, tuples are look similar to the lists, but in reality they are immutable ordered collections. So tuples are used anytime you don't want somebody else that is maybe using the code or that is looking at the code to modify the content of the tuples. Tuples are designed to store information, to store any type of information. And since they are not supposed to be modified, they do not present any type of method like remove, like pop, and so on, because you are not supposed to change what is contained in the tuple. You cannot even access one element in the tuple and change it directly, because you will get an error. So if, for example, I say my tuple in position 0, instead of 1, I want it to be 10, I get an error. Tuple object does not support item assignment. This is because tuples are created to remain as they are. Okay, you can obviously find ways to force modify the tuples, because Python is generally a flexible language that allows you to do many things to your expenses usually. So if you see tuples, bear in mind that they are not supposed to be modified, okay? You can still access the values, use the values, because of course they are made for this. You can index the values the same way as we did with lists. So I can print the value in position 0, that is 1. I can do a slicing indexing, as we saw before. Once again, it counts the starting value of the range, but it does not count the ending value of the range. And then we can do a few things with tuples. So for example, we may have different tuples, and you want to merge them together to have all the information in the same place. So let's say put some random value in this tuple. And I can concatenate it. Once again, we can use the plus operator because it's working the same way as for the lists. So I have tuple 1 plus my tuples. Can print it. And as you can see here, we have 3, 4, 6. And then we have the content of my tuple. So we can concatenate it. We store the data together. Or maybe we want to do some alignment between the information contained in the tuple and the longer signal that we have. So we can replicate the tuple. And this can be done with the multiplication operator. So replicated tuple will be my tuples 3 times, okay? Repeated 3 times. If we go like this, we have 1, 2, 3 through, and then we start again 1, 2, 3 through, and 1, 2, 3 through. So we have the same tuple that is repeated over time. As it was before for the lists, this can create confusion potentially, because you will not understand if you are doing a mathematical operation or not. But if you look at what is contained in your tuple, what is contained in your tuple, you see that it's a tuple, because it might have another name, obviously, and you will know that there is no way that you can perform a mathematical operation inside there. So you can, let's say, discriminate what is happening. Okay, these are important, let's say, basics. You might need them, I don't know how much. You will definitely need lists quite a lot. Tuples are less commonly used, at least in data science, because you need to continuously modify and update the data. But of course, you will use lists to contain and modify information, But you may want to use tuples, for example, when you need to store a lot of information that is important that remains as it has been created for safety issues, but also because tuples are very memory efficient, so they will occupy less space in your memory to store information. Fantastic. So we can move to the next topic. Next topic starts being a bit more, let's say, I would not say complicated, but there are more things to do definitely. And this is the dictionaries. We saw last time the dictionaries because the EMG file that we import with the openhdemg library is a dictionary, which is essentially a combination of keys and values pairs. So dictionaries are similar to lists because they are both mutable, so they can continuously change their content. They can increase their size, they can become smaller, they can be nested, so a dictionary can contain other dictionaries or other lists. The same way a list can contain other lists or other dictionaries or whatever it is. But as you saw before, lists need to have a logic behind how they are filled, because otherwise you will never understand what they contain as they grow, because values do not have any label, while dictionaries can be extended without worrying of finding again the correct element, because they have a unique key that is identifying the content of the elements in the dictionary. Dictionaries are created with curly brackets. So this is one of the use cases of curly brackets that, as I told you last time, are not really common in Python. So as we did before, we use the curly brackets as we did for the lists. But in this case, we need to specify key value pairs. So I specify my first key, can be name. I use the colon to separate the key from the value. So in this case, the value will be John. Then I put a comma, which will separate the next key value pair. So I can put age and 30. So I put an integer. Once again, the content can be of any time. Also, the key can potentially be an integer, so you can do this. It doesn't need necessarily to be a string, but for this example, it makes more sense. So you can write city, and we put New York. So this dictionary is containing information about John. We know that about a person. We know that the person's name is John. We know that John has 30 years, and we know that he lives in New York. Indexing is done always with the square brackets. But this time we do not access the position. There is no way to access elements by position, and it doesn't make sense in dictionaries. This is because dictionaries store the key value, the keys as hash codes, so they are something that can be reconstructed from a text or from a value that can be similar to text, so it's not a position. So if I want to know what's the name of the person, I write name. So the name is my key, and then I should see the value. Okay, indeed, this is John. Similar to lists, also the dictionaries have methods. The method we saw last time was the keys method that is showing us what are the various keys, so name, age, city. Similarly, we have values. So in this case, we will have John, 30, and New York. This is explaining you how the dictionary is structured. But then if we did not create the dictionary and we want to explore everything, we can also use the item method. So as you can see here, the first item is name and John, key and value. And the second one is age and 30, key and value. And the third one is city and New York, so key and value once again. Okay, so you know how to access the dictionary, you know how to create the dictionary. So we can try another small hands-on task where I ask you to access the value contained in the key age. So you need to see 30. Then you need to replace 30 with 40. So we make John a bit older. Then you need to add a new key value pair and remove an existing key value pair. So for these last two tasks, I tell you that this can be done with the pop method, the same way as we saw before for the lists, while this one can be simply done by indexing a new key that does not exist, okay? So let's say you write John, my dictionary, square brackets, happiness, equal to any value you want. This way you create a new key value pair. So guys, any feedback on the class itself is well appreciated also during the class because these things are boring always. So if you think we can make them funnier, your opinion is more than welcome. Okay, I go on with the first 2 points, which were quite simple. So we can simply visualize what's the age of John. Now, maybe what is a bit trickier is to change the age of John. So as I told you before, we simply need to access the element that we want and replace it with something else. So instead of 30, we make him 40. Right, so now John is 40 years old. As I told you before, we want to create a new, simply any new key value pair. So as much as your fantasy allows you to do so, we can create my dictionary. Let's say I do not have much fantasy, so we know that he's a male. Okay. So we can also better visualize the entire dictionary. So now in the dictionary, we have the name, the age, the city, and the gender. Okay, let's go to the last task. So once again, remove value because I'm using the pop method. The pop method, the same as before with the lists will give me the remove value. So I want to remove city. So where my dictionary, pop, it has yellow, and I simply need to insert the key. Okay, the key in this case is city. We can print the remove value and we can print the modified dictionary. Okay, so the removed value is New York and the modified dictionary does not have the city anymore. Okay? Good. I don't see any comment, so I assume that everything is fine. And we start moving to a bit more interesting, maybe concepts, because this will be more important in your data analysis, but also because they will take more time to be learned. Now, we start looking at data frames. Let me write the names. Okay, data frames. What are data frames? We saw them last time. Data frames are tables, simply, are very advanced tables. With data frames, you can do a lot of tasks that, of course, go from storage to data manipulation, but also data visualization. And they are not part of the standard Python library. So all what we saw until now is part of the standard Python library. If you remember last time to use openhdmg, we needed to import the openhdmg library. Today we did not import anything because strings, lists, tuples, dictionaries are all contained in the basic Python installation that you performed. But some more advanced structures, data structures, need to be installed separately. You install openhdmg, so you already have all these other libraries that are necessary. So the only thing you need to do is to import them. To use DataFrames, we need the pandas library. The name is funny. We can import it with the short name PD. Pandas is the library dedicated to the management of tables that are efficient in data storage, in particular for data analysis. Doesn't necessarily need to be numbers, so they can be any type of data, but they're specified in data analysis. So we have imported our library with a short name. We can create the data frame in different ways. So in this case, I take a dictionary that I already have. So you know how to create a dictionary. You can quickly take it from the code I shared yesterday. So we create a new dictionary that has keys and values. So it's quite simple to understand how a dictionary can be converted in a table. Every key will become the name of the column, and every value will become the content of the column. So to create the data frame, which I will call df, I can write pd, which is my pandas library, data frame, which is another class that is used to create a data frame from some value. In this case, I want to create it from data. Okay, and then I can visualize my data frame. And as you can see here, my data frame has 3 columns and 4 rows. The first column, name, contains the name of different people, age contains the age of different people, and then city contains the place where these people live. So this is similar to dictionaries. It's much more understandable for the final user, but it has some constraints. So for example, you see here that all the keys of the dictionary have the same number of elements. So you cannot have a dictionary with any rules, because in a dictionary you can put everything. But if you want to create a table, you need to have at least the same number of elements. They don't necessarily need to be the same type. So instead of 35 here, I can put a string, which is 35. And I create my table. In this case, everything is converted to a string because the type of data needs to be coherent inside the column. But pandas is quite smart, so we'll take care of all the conversion and we'll give you the table you need. But all the columns need to have the same dimension, okay? Tables can be quite long, so we may want to look at the title, at the columns that there are in the table, because they are, of course, the most important information that we need to explore the content of the table. So we can use attributes. Attributes are a new concept. I will explain to you in a few minutes. But in this case, the attribute is columns. It is blue. It is no longer yellow. We don't need the parentheses, because if we hover the mouse here, it says this is a property. So we don't need parentheses. Now I will explain you why. We print it, and you see we have name, age, and city. So we know what are the columns of the data, the pandas data frame. Let me take for you an explanation of this because it's important. So before we saw methods that are essentially functions that need parentheses, but now we understood that with the dot, we can also access properties which do not need parentheses because do not take any parameter. So they are not a function. Properties and methods or functions serve a different purpose, and in particular the properties describe, let's say, the state of an object, they can be quickly accessed to look at the object itself. These are used for storing the data or state of an object in a way that it can be informative to the user, so that the user can interact with the object easily. On the other way, methods are performing some actions. Okay, let's make it simple. If you want to do something, actually, you can use a method which will take your inputs, do some operations, and will end up modifying the content of your table or how the data is presented in your table. So the properties represent the state of the object, but methods represent the behavior of the object. So for now, it's just important to understand that they don't need parentheses, because if we put parentheses here, we get an error. And it says the object is not callable because it is not a function. So today is going to be a lot of information. I just trying to repeat them because it's difficult to get into them. But now we look at a number of properties that are informative. So now we looked at the columns, but as you saw, we also have rows. This is called index. The index is giving you the name of the rows, because it's very nice that you can also create a labeled index. Let's try to do that. When we build the data frame, we can specify the index. If this works, we have 4 elements. So we need an index of 4 elements. A, B, C, and D. Let's see if that works. Okay, fantastic, it did. So as you can see here, my table has the columns name, age, and city. And now the index is no longer a progressive number. So it's not 0, 1, 2, 3, 4, but it's whatever I want it to be. So it is A, B, C, and D. And it is very efficient because it gives me one more degree of freedom to organize and access my data. But we may also want to look at the type of the data. So in this case, we use the property dtypes. Okay, and it is telling you the column name contains an object. In particular, it is a string. The column age contains an integer because it's an integer number. If we put even only one float, it will convert everything to float. So in this case, age became a float number, so a number with decimal places. Then we have the city. Once again, it's an object because it is a string. Okay, very flexible tables. And now we may want to look at just some values in the table, so we can use indexing. Tables are working in row major. That means that the main way to look at the tables is the column name. And this is obvious. But this is fundamental because it's the approach that is going to give you the best performance when working with this data. If you start working with rows, indexing rows instead of columns and so on, it means you organized your data frame in the wrong way and your code will be really, really slow. If we simply want to access a column, we can use a normal indexing with square brackets. So we can do data frame and we can index name. Okay, as you can see here, we have John, Emma, Ryan, and Emily, because this is the content of the name column. Of course, you can do more complex indexing. You can index elements both by position or by label. Let's start looking at it by position, which is named iLoc, which is integer location. So we can say 0. Let's display once again the data frame. So with the, and this time we have still a property, so we don't, it's not a function, it's still a property because it allows us to look at the content. So as you can see here, my table is this one, and accessing the position 0, I am accessing the row 0, which is A, but it doesn't matter if it's named A because we are looking at it by position. Okay, so we have John, 30, and New York. We can index both rows and columns. If we do not specify anything, we start from the rows, because usually encoding the first element in a, let's say, two-dimensional structure is the row, the second element is the column. So for consistency, also pandas maintain the same structure. So we can say I want row 0 and then the column 1. So I should get 30, which is row 0, column 1, and indeed this is 30. I can do range indexing, better say slicing. So let's say 1 to 4. No, I don't have 4 elements, so 1, 2, 3. And as you can see here, we have age 30 and city New York, because row 0, column 1 and 2. Okay, so age and city, because we take the starting value, but not the ending value of the slice. I insisted many times on this concept. You are now annoyed by it, but you will see that all your knowledge is now disrupted by this next thing that we will see. Because instead of integer location, I can also locate elements by label. So in this case, I use the term, the property lock instead of iLock. And by using lock, I cannot specify the position like this, but I need to specify the row A and the column, let's say name. Okay. So as you can see here, we get John because it's in row A, column name. I can also use a range, so I can say I want my columns going from name to city. So what will happen now? I mean, you may think we will index name and age, but not city, because when we use slicing or range indexing, we do not consider the last element. So let's see what happens. And no, this is not the case because we got name, age, and city. So this is an exception, difficult to understand, very simple to make mistakes because it's just one letter of difference. But when you are indexing elements by label, you consider also the last label because it's no longer a numerical indexing, and you will no longer have issues because you are indexing one more element that is, let's say, expected in a base 0 order. Let's hope we didn't make too much confusion, but when you work with data frames, this is an enormous obstacle and an enormous source of errors. So indexing element by position requires you to specify one more element than the one you want. Indexing element by name will not require that. Okay, this is one of the few exceptions you have in Python regarding indexing. Okay, I have more material, but I think for today we did quite a lot. So we will only finish data frames. I will ask you to do one more hands-on section, which is this one. So I want you to create a new data frame with 5 rows and 5 columns. You can just quickly modify this one that you already have, so we save time. Where column labels are a string. So let's take it name, age, city, and whatever you want. Don't put zeros, one, etc. Use strings. Once you did so, you can access the second to the fourth element included. So the second to fourth row of the third and fourth column, both using lock and iLock. Once you've done this, I want you to create a new object, as we have done before with equal. So new object is equal to that. And this new object should contain all the rows and the first 2 columns of the previous data frame. We take 5 minutes for this one, which is a bit longer. So creating a data frame, I think it's been quite simple. We just added few random elements here and there. So we now have 5 columns and 5 rows. And the first task we need to do is to access the second to fourth element using both lock and iLock. Okay, let's start with lock. So, data frame. So we are locating the elements by label. So in this case, my second second is B. So I want row B to fourth D rows. Then the columns, I want third and fourth column. So third and fourth can be obviously accessed as a slice, as we did here. So you can third and fourth, C, T, and D will be let's see what happens. Okay, so we accessed our columns, our rows, but I just want to show you that instead of a range, you could also pass a list, which is not necessarily needs to be seen as a list, but as a collection in general. So let's say maybe I don't want consecutive elements, but I want age and also the column D. I can do that. And I get age and D. So I can either pass a slice or a collection of elements. And this definitely will not work if I use iLock because I'm locating everything by position. So I want the second element, which is the number 1, up fourth element. So I need to specify 4, if I'm not wrong. Yeah. And then the third and fourth column. So this will be 2, 2, 4. Okay, so we once again have C, T, and D. Before we did with lock, and now with iLock. Okay, very last task. We need to create a new object with all the rows and the first 2 columns. So I want a new data frame to be my data frame. I can use either lock or iLock, doesn't make any difference, just need to change the syntax. So I want all the rows. If I want everything, all the rows, I simply can use the colon, then comma, and specify the columns that go from the beginning. So I can use another column that is saying from the beginning, it doesn't matter how long it's my data frame, up to the the first column, so the end of the range, -1, which will be the same as writing 0, 2, okay? So it's exactly the same thing. But I can avoid 0. And this can be useful, not really for the beginning, because the beginning is always 0, but I could do, I don't know, I want to access the elements from 1 to the end. So I do not specify anything, I just leave the colon as it is. As you can see here, we have a name, so we don't have any more name, age, city, and no, I need to print the new data frame. Okay, if we do it like this, I do not have a name anymore because I am printing from 1 to the end. But regarding the task we had to do, we can say 0, 2. Okay, we are done. I mean, we could talk a bit more about data frames, but I think it's okay if we stop here for today. So today was long, today was boring, but this is a compulsory part to go through. I hope that being the class a bit interactive helped you to don't get too bored. We have a few more concepts to see. We need to look at arrays. We will finish data frames and look at arrays in the next class. But I will share the code that is more or less the one you already received. But I will also include the solutions if you need. And I also encourage you to ask in the discussion forum if you have additional questions, because I guess there will be questions. So guys, thanks for listening. Once again, if you want to give us feedbacks, you are always welcome.